So the quantum numbers is the one that we are going to use to identify or to locate the possible position of an electron. No? To formally define what quantum numbers are, the quantum numbers are the set of numbers. No? So basically, we have 4 quantum numbers. And this set of numbers are used to describe the position. And when we talk about the position, now we understand that it's not the exact position, but the possible location of the electron and the energy of the electron in an atom. No? Say for instance, to relate it in real life, if you have a friend, no, or if you are a JNT driver, no, or a Food Panda, ano pa mga delivery, LBC, no, they are like the quantum numbers, or they are the locators. Say for instance, saan matatagpuan ang pinakapoging kachimek? No, these quantum numbers might help you. Now, the 4 quantum numbers. Now, if we would place it in an address, the first quantum number would be the Camarines Sur. No, it's a bigger area. No, pinakapoging kachimek nasa Camarines Sur. That's the first quantum number. Second quantum number would be a smaller scale, no, but still big. No, Naga City. No, it's in Naga City. And then the third quantum number would probably be the barangay. It's in Cararayan. No, and the last quantum number will tell you about the behavior. No, so lagi ito yung mga minamay-day niyang mga places. So probably nandito siya sa part na to, or papunta siya lagi doon pag sumasakay ng tricycle. So baka nandun yung bahay niya. No, but we cannot again tell the exact place, no, or the exact address. No. And to further understand what I'm saying here, now let's discover the 4 quantum numbers. So the first quantum number is what we call the principal quantum number. Now, it's principal because it's the main quantum number. Now, it's signified by n, no, small letter n. So don't forget that label, the small letter n. Yeah, small letter n for the principal quantum number. It tells us the energy level of an electron. So, if I have one circle around my nucleus, my n would be 1. So, meaning, this might be my Camarines Sur, no? This might be my Bicol, this might be my Philippines, and this might be my world and Miss Universe. Yan, sarot. As we increase the energy level, of course, the energy level or the circle, no, the diameter and the radius also increases, no. So mas malapit sa nucleus, mas mababa ang energy level. So if n is 1, no, meaning the possible location of the electron is here, no, nandito si electron. If n is 2, it's in this particular region of space, but still it includes this, it covers, no, this place. No, if n is 3, it's in here, no. If it's 4, and so on and so forth. So yan lang yung tatandaan. The first quantum number is the principal quantum number, and it tells us the energy level, no, energy level of an electron inside an atom. Some books would call this energy level shell, no, or shells. So okay lang naman kung alin yung gusto nyong gamitin, energy level or shell. Now maybe you're using other books. This is our first quantum number, the principal quantum number. So first question, how many numbers, or what are the possible numbers of n? As of the moment, we only have until 7, no? 7 quantum numbers. N is 1, n is 2. Paano natin to malalaman? No, you can count the period in the periodic table of elements, no, until francium. No, from hydrogen pababa, that's 7. No, 7 energy level. That's why periodic table again is amazing, because it was arranged in such a manner, no. Sige. So just to have a view of how the coverage or the area of the primary or the principal quantum number is. So ganyan, no? It as the n increases, no, the region where the electron might be also increases. All right. So the second quantum number is L. It's a cursive L. Cursive letter L. Now, we call it the angular momentum quantum number. So, the angular quantum number or angular momentum quantum number, signified as cursive letter L, describes the general shape of region an electron occupies, no, or the shape of its orbital. So what do we mean by that? The orbitals, no, maybe you are familiar, SPDF has different shapes. No, meaning if an electron is found in the s orbital, no, the s1 and s2, the electron will be in this particular sphere. No? If it's in the p orbital, it should lie in this bow tie plane, no? Seemingly a bow tie plane. However, no, since we are talking about in 3D, the z could be, this bow tie could also lie here, so forgive my drawing, or it could also lie here on the x-axis, no? Because we are talking in the 3-dimensional. So the D would also have that possibility, while F would have a lot of possibilities. So medyo mahirap siyang i-drawing. So let's use some image that might be able to help us. So when we are talking about the S, no, S sublevel or the S orbital, a sphere, no matter the orientation is, or no matter where the orientation can be found, kung y or z or x-axis yan, it still be a sphere. So S only have one possible shape, while as I've mentioned, P orbital will have 3 possible shapes. So bear with me muna if this seems very confusing now. 5, or maybe this is already making sense. D has 5 possible shapes, no, or possible orientation, while F has 7 possible orientations. Medyo may pumapasok na ba sa isip mo na, meron na? Kung wala, okay lang. So, we'll move further, no? See, angular momentum quantum number has an equation, L is less than or equal to n minus 1. So, say for instance, if n is 2, L could be either 0 or 1. So, anong meaning nito? Sir, bakit kailangan natin itong aralin? This is it now. No? Hopefully, it will make sense. Now, using the formula, so the first principal number, the first quantum number is the principal quantum number, which is n. The second is the angular momentum quantum number, which is a cursive L. Now, these are the first 2 quantum numbers. Now, the first location of our address. Now, these are big, but this might help us. So, if n is 1, what is or are L? So, using the formula, if my n is 1, so forgive my cursive L, this would be 1 minus 1. So, L should be a positive integer. I forgot to tell you that. So, it would be less than or equal to 0. It cannot be negative using this equation. So, therefore, there is no whole number lesser than 0. So, L is just equal to 0. Right? So, that is if my n is 1. So, surprisingly, yan, nawawala ang mga image. Right. Surprisingly, these numbers are very interesting. This angular momentum quantum number in particular is very interesting. This 0 corresponds to a specific orbital. If in mathematics we use letters to represent number, diba, we use variable x, variable y, variable a, variable b. In chemistry, specifically in quantum numbers, we do it around. We use numbers to represent a certain orbital. So, 0 represents the s orbital. Sige, I don't know if it's making sense already, but let's proceed further. Now, if n is 2, what would be the L? Let's check it out. Using the same formula, you can follow if you have notes with you. N minus 1. This will become 2 minus 1. And then moving further, this will become 1. 2 minus 1 is 1. So, L again, could be either 0 or 1. Now, 0 represents S. Again, sabi ko nga, numbers are used to represent letters, no? And particularly these orbitals. Therefore, 1 represents P. Very good. Alright, let's proceed. What if N is 3? So, 3, that would be 3 minus 1. So, di ko na ikakopy yung equation sa taas para mas mabilis. L is, yan, that would be 2. Yan, hopefully you can follow. And then, L would be, what are the possible values? 0, 1, and 2. Very good. No? Hopefully you're getting it. We are actually getting now the first quantum number, the principal quantum number. And then out of this one, we are getting the second, no, quantum number, which is the angular momentum quantum number. 0 represents S, 1 represents P, and then 2 represents, yeah, very good, D, no, the Power Rangers, SPD. Yan. And moving forward, no, if N is 4, yan, if N is 4, L would be 4 minus 1. Don't forget the less than or equal sign, kasi minsan dyan namamali ang mga bata. And L, that would be L is less than or equal to 3, and L is, or the possible values for L is 0, 1, 2, and 3. Now, 0 corresponds to S. Very good. Sana nakasabay na. 1 is P, 2 is D, and lastly, 3 is F. Ayan, nakuha. Alright, very good. We have the SPDF. Now, what do we mean by that? Now, if you noticed, no, as we increase the value of N, no, as we increase the value of N, the value of L also increases. Now, if N is 1, the L is only 0. If N is 2, the L is 0, 1. If N is 3, the L is 0, 1, 2. Now, by using this formula, if N is 4, what are the values? Eto na. That's 0, 1, 2, 3. No? And again, these L values, these L angular momentum quantum numbers corresponds to the orbitals. And amazingly, this is the reason, no, why we have the Aufbau principle. This is the source of our electron configuration. So, we have now the energy level N as 1 and 0 as the angular momentum quantum number, which is S. That's why we have, in the first layer, or if the first level, we have 1S. We have 2, 0, that's your 2S. However, in the second energy level, it could have also another orbital, which is the p orbital. That's why we have 2p as our second orbital in the second energy level. And as we proceed further, this will become 3s, 3p, and then 3d. So, hindi ko na isusulat. And then 4s, 4p, 4d, and 4f. And as we proceed, we can actually build the electron configuration and follow the Aufbau principle by using the first two sets of quantum numbers. Amazing? Amazing. Diba? Hopefully, no, na-get.